All right, let's look at one in Achieve 3.1, number 14. Previous video I did, I think, number 9, which is very similar to this one. And when you look at the question, of course, a different function. And this function is a function of t, which caused me a little bit of stress a couple times. Sometimes we're used to using the variable x, and Achieve will not let you replace t with x in this problem, which is important. And so you just need to be careful about that. It's also a little bit different than number 9. The way they wanted the answers, I thought, was kind of strange. At any rate, you start with this function, and they're asked to evaluate the difference quotient, like in number 9 as well, and this time at a equal -1. So here's the difference quotient. They give you that. So you're just plugging in. Of course, if I plug in -1 into the function, simplify, get the square root of 3. So this becomes f of t, which is the square root of 3t plus 6, minus f of -1, which is square root of 3. And then t minus -1 is t plus 1. Now, in the previous problem, we went ahead and simplified. You could actually simplify by multiplying by the conjugate of the numerator. You can rationalize the numerator. But this is what they want in that answer, just that changed expression. That's the difference quotient for the function at a equal 1. Now, the second thing is to find the derivative at -1, which is the limit as t approaches -1 of this difference quotient. So now we're just taking this expression and plugging that in there. So we have this. Now, the question is, what's the limit as t approaches -1? Obviously, I cannot plug in directly -1 for t because I get 0 over 0 if I evaluate that. So now we want to simplify this, see if we can get this equal to a function that is actually continuous at -1. And if you remember the technique we use in finding limits, we're going to multiply the numerator by the conjugate, which is the square root of 3t plus 6 plus the square root of 3, right? So I just changed that negative to a positive. Of course, what I multiply on the top, I have to multiply the bottom as well. So I'm multiplying by 1. And the reason we do that is if I FOIL out up top, the square root of 3t plus 6 times the square root of 3t plus 6 is just going to be 3t plus 6. Notice the outer term is positive root 3 times root 3t plus 6, and the inner would be negative root 3 times root 3t plus 6. So the outer and inner are opposites. When we add them together, they go to 0, and we don't have any radical anymore, because the last term, negative times positive, is negative what? Root 3 squared is equal to 3. So notice when we FOIL out the top, we get that. Now the bottom, you don't want to distribute this, FOIL out down here. Do not FOIL out down here. You want it factored. We're trying to simplify up top, and we're going to recombine and then refactor. But in the bottom, we just multiply. Now this t plus 1 needs to be in parentheses. If it's outside of parentheses, then that's incorrect, right? It's t plus 1, the whole thing, times, and in parentheses here as well, this expression. So we don't want to FOIL this out. Leave it alone. It's factored. It's in a good form. Up top, we simplify. 6 minus 3 is 3. And then I can factor out that common 3, and I have this expression. And there we see it. This t plus 1 is a common factor now in the numerator and denominator. Notice the denominator I never do anything to. I leave it alone each time. It's already factored. So I can divide numerator and denominator by t plus 1. I get this expression, and now this expression is equal to the original expression up here for all values of t except at -1, and it's continuous at -1. I can plug in directly now to evaluate this limit, replace t with -1. I get -3 plus 6 is 3, so I get 3 over square root of 3 plus square root of 3, which is 3 divided by 2 square root of 3. So there's the actual result, and that's what they want in the box. Now you could rationalize this if you multiply top and bottom by the square root of 3 over the square root of 3, we would get 3 square root of 3. Square root of 3 times square root of 3 is 3. 3 times 2 is 6. 3 6 is a half. You get the square root of 3 over 2, which I think is a little more simplified, but they accept this answer. I didn't try this one, so I'm not sure if it would accept that one, but it did accept this one. So I just left it at that. Now, again, when I'm asking this question, I'm sort of combining these two as one. In other words, I'm just going to ask you for f prime of -1. So you're just going to do this part. Okay. I mean, obviously you need to be able to do this to get the starting expression, but more importantly, you have to show algebraically all these steps. And notice again how I've got the limit sign each time until what? Until I do the plug in. The minute I plug in, there's no limit sign anymore because, you know, I have an actual value. If I can plug in and get an actual value for the functions we're dealing with, we will get the limit that way. So that's the first two parts, you know, first blank, second blank, and the third blank is the equation of the tangent line to the function f at a equal -1. So we just found the slope at -1, which is f prime of -1, which is this value here. And our point of, excuse me, our point of tangency, let me get something to drink here. Excuse me, our point of tangency, a is -1, f of -1, which we found above was square root of 3, all right? And so we have our point of tangency, slope m, and x1, y1 is our point. So I'm plugging in to this. Now here's where you got to be careful. I'm so used to doing x minus x1, but it's t minus t1. Remember, it's a function of t. So you've got to have t here. When I plug in y1 square root of 3, the slope m, right, is that, and then t minus a -1 becomes t plus 1 here, obviously. Distribute this 3 over 2 square root of 3, and I get this plus this. And then I need to add the square root of 3 to both sides. So if I take this expression and add the square root of 3, I did that over here, 3 over 2 square root of 3 plus the square root of 3, get a common denominator, which is 2 square root of 3. And square root of 3 times square root of 3 is 3 times 2 gives me 6 up top there. So 3 plus 6 is 9 over 2 square root of 3. So that's the, if I take that expression and add the square root of 3, or I'd have to add that to both sides, solve for y, I get that expression. Again, if you had rationalized, I think it would look a little bit nicer down here, but it accepted this as the answer. Actually, I think you plug in, it's already got the y equal, so be careful. You don't need the y in this particular case. I think it's got y equal, and you just type in that. So that worked for me. So, you know, just be careful with a lot of these problems with the variable. I know that's a little frustrating. You're used to using x, but read it carefully. If there's a t as an independent variable, you have to give the answer with that independent variable. Okay, so I hope this helps with this one. I know sometimes the problems are a little frustrating if they're not perfectly in the right form. But I think you take that as a learning process to be careful, to read questions carefully, take your time. A lot of you have, we all have trouble making, you know, simple mistakes, but that's a way to keep us from making those mistakes, or at least, well, catching it when we do. Okay, so I hope this was helpful.